Okay, I'll start my presentation. Thank you for being here. I think I'll be the last speaker for our breakout. And now I see that there are a lot of people here. And I think thank you for attending my presentation. And I think it's much better than my last conference. And I have about 13 participants during that session. And my name is Du Jun, and today we'll talk about the KBS. So I will talk about the things related to the Kubernetes applications. And I will talk about Kubernetes networking. It's called endpoint IP. For the single pod, single IP, for the pod and node without connectivity, and we can implement it. And it's called Kubernetes. When you write a plugin, as long as they have these two functionalities, you can call it a Kubernetes plugin. If you have the CNI standard, you can call it the Kubernetes CNI plugin. Let's say the Flannel is not a CNI plugin, but actually it has two functionalities. So this is called the Kubernetes CNI plugin. So the client creates a pod and it goes into kubenet, and it has two big interfaces. One is CNI, the other is the CNI, and it can connect it with a Docker and a container. You can create a container. After the creation of this container, and it can initialize the pod container. Initialize the namespace with the root back without EVP, and that is created by CNI plugin. For the plugin, there are a lot of plugins, like the bridge, PGP, NetVLAN, a lot of plugins. If we choose the bridge network, the bridge plugin is responsible for the network that is just initialized and can create an init, and it can have an IP address. For the distribution IP address, it can be done by the local plugin. So when it's done, a containers the containers LO is out, ETHO came into existence, so the nodes and containers communication can be done, but for the pod-to-pod, node-to-node connectivity cannot be done. So must have the Flannel Calico overlay and underlay, all these big 3 layers. And with this, can create a tunnel or the encapsulation to implement the connectivity among the pods and nodes. We just mentioned the CNI. What is CNI? CNI, to make it simply put, it can be standard of Linux container network. In terms of standard, it must be a spec. In order to save the file, I try to describe such a pod network. Within the CNI, it has 2 types of interfaces. One is to create the network. One is add a network list. Within this interface, there are 2 parameters. One is config, there's a runtime config. When delete one pod, it will call the cleanup network interface, delete a network and delete a network list. So here are 2 parameters. One is a network configuration, another round configuration. Within the Kubernetes, CNI is a middle layer. It just blocks the sensing of the bottom layer plugins. Flannel Calico and Vue and CNI are the third-party plugins. CNGA is a multi-network plugin. It failed to implement a single pod. Why do we need to have the QoS support?
For users. They don't want to improve their performance by large scale, but they hope that their performance can reach the similar network performance as the local applications. And also we have the multi-tenant environment, and they don't want to compete for the same environment with their noisy neighborhood. And for the cloud providers, they need a way to isolate different tenants or applications. And to avoid the competence for resources. Another option is we have lots of the real-time traffic and streaming, the video, audio streaming. So we have lots of bandwidth. Maybe this will surpass the traffic that could be covered by the node. So how to handle the network flood is very important. And also they will charge with different QoS levels. For Kubernetes, why we should support for the Kubernetes? The Kubernetes has become the default standards for the orchestration container. And it will better support for video and video streams and IoT scenarios. And these are very sensitive to the bandwidth. They can offer better support. The Kubernetes scheduler for the pod performance. The resources will compete with each other, so they will have isolate deployment. And if their scheduling structure is not that satisfactory, then from the network level, they can still finish the isolation. So Kubernetes can finish more in terms of the QoS and isolation. And in Kubernetes, kubenet is very conventional. The 1.11 Kubernetes has become the Kubernetes network. Well, Kubernetes will define API. The pod network will have single pod, single IP to deploy and to implement. But in 1.11, before the Calico, they have the kubenet. They resolve the communication within different nodes. They don't have the work policy, so this will be deleted. But they have the bandwidth control capability. And they should have the downward compatibility. And if they just scrap all these functions, then how to deploy all these functions? In the default CNI, before I introduce this part, let's have a look at the basic network implementation. 3 parts. One is the management level. They define the policy and forward the policy. So for different networks, it will have the harmonization work or coordination, or to identify and mark the different packets to mark whether this is high level or low level to a specific gateway, or within the gateway, what kind of technique they need. Queuing. The packets need to queue, or scheduling. They have lots of queues to queue the packets and to ship the traffic, to manage the traffic. Later, I will introduce to you the difference between shaping and management of the traffic. These are very typical implementations of QoS. I just mentioned the techniques. So first of all, it relates to the congestion control. This gateway. It has 10 KB, and if in 1 second it comes into 20 KB, it needs to control the congestion and to have the priority for the congestion, or to have different characterization for the priorities. In terms of queue management, the high priority queue And the low priority queue, if they have 300, then how to prioritize to scrap them? So they will scrap the low priority first. So the queue management relates to several issues. First of all, they will have the algorithm to make sure every queue has at least some vacancy. And don't make the queue very congested. And they will make the low priority packet very congested first. So the third part is link efficiency. What does it mean? A brief example. Video audio streaming, 100 MB. Management, maybe a byte. This 100 MB goes through gateway. The control byte goes later. Then in Linux, the normal gateway will do like this. They will separate. For example, separate this 100 MB into 100 small packets and to have the intricate. The small packets will go out first. And then comes the traffic shaping and policy management. What's the difference? The traffic shaping relates to the cache. And for the to cache or to store the packets temporarily relates to several algorithms. We use a token bucket. For instance, we'll limit the bandwidth. If it surpasses this bandwidth, this will make it into cache. So it will need a bucket, like the bucket of drip, water drip. In our example, a token represents 1 byte. For instance, 1 second, we have 10 tokens available. Every time when we have 1 token available, we'll send 1 byte out. In some other parts, service end or flow management, we have lots of applications, but one significant problem is burst. For instance, the average traffic is 10 per second. The former minute, we don't have any packet. The latter minute, maybe we have burst. So on average, the latter minute, maybe we'll have 20 per second. So burst will happen in the second minute. I'm sure that you are all familiar, are clear about this. So we can use Linux TC for managing this. The network flow control. TC composes of 4 subnets. This is a system, not a simple tool. TC is a kind of tool. TC also has lots of the subnets, and the performance is very strong. TC composes of 4 systems. One is identification packets on different networks. The packets will have identification and marking. And in the gateway, we have a filter. If you can match this packet with a filter, you need to go through the follow-up process, or you can send it to the gateway. If it can perfectly match, it will go through the flow management or traffic management first. For example, this gateway. In normal cases, this will go into cache. But if we have limited cache, only work for 1 MB, then the packet with the larger size will be scrapped. If not scrapped, this will go through scheduling system. Lots of arrays. These packets will access to 0 interface. This will go into the sub-queue, or if access H0 will go into the D subsystem. So this is the process of scheduling. And after entering this queuing, when will the queue relates to shaping? When we have the ready token, then this will go out of the queue. After these four subsystems, the packets will enter the gateway or will leave the gateway. So TC is responsible for sending, not receiving. If you send this out, then this will go through these four subnets. This is the TC sample command. For example, if we will define, by the way, we know TC can be used on one gateway, but its usage is to limit the flow by direction. For example, if we want to confine the destination 172.717.0.4 traffic, how can we do? The TC command and queuing management to control, and then for the root gateway to add it. And in the default, by default, we will make the 30. After comma, we have the 30 and then default. On the second line, this flow will be restricted to have a kind of a rate at 10 MB, and we use this protocol. And we control the traffic to comma 1. We counter the corresponding IP. The IP parent is 1, 0. And then to match the IP address. So we can send to this destination address. The maximum traffic is 10 MB per second on average, very fast. The CNI plugin in Kubernetes will finish management. So in the Kubernetes, if we want to control the traffic, in CNI we need to finish support work. The BugNet plugin will configure filter and flow. The algorithm uses token bucket, TB. To limit the up and down bandwidth, but TC is only responsible for sending. So we have a small trick. Uses the internal gateway. If we want to limit ETH0 to VETH123 flow bandwidth, how can we do? We can add one intermediate gateway, which is IFB. And this gateway can receive and send flow. So we can use it to send, which is the ingress of VETH123. This is a small trick. The config list. Bridge plugin, Calico plugin should be collaborated with each other for bandwidth control. The others will be responsible for the AIP assignment, how to use them. This document, if you're familiar with this, you will know this is CNI config. We use it to describe the gateway, which is mynet. the plugins. We have a plugin list. And we have the type here, which is the bridge network. The IP address assignment from the host local to start. The subnet is so these are the types and the subnets. The node A and node B will have their assignment. So we have the this for the harmonization of different nodes. This is the bandwidth control plugin. The name is slow down. To slow down the flow and the ingress rate. The ingress rate is 1, 2, 3, randomly assigned. And we have the bit per second, the burst, the maximum allow ingress is 4, 5, 6. The token 8, if the flow before is very slow, maybe later it will burst out. So we need to slow down egress rate, the upward bandwidth. You can slow down the burst flow and the average flow. So you have this plugin list, and to assign the IPs, the gateway, upward bandwidth, and the downward bandwidth and the average flow. So in the CNI level, we can manage this, and in Kubernetes, how should we do? We can use the pod and patient. We have the CNI and Kubernetes network drivers. For example, if you use a CNI driver, we can assign the bandwidth. In the red part, we have the egress. The egress is 1M, and the ingress is also 1M. Most of the network plugins do not have the traffic management capability, so the CNI plugin shall be put into the OPT CNI beam, activated by Kubernetes to read this catalog, and at the appropriate time, this will call the binary and the file in the and then we can put the above mentioned part into here to activate the bandwidth. And then from the management to data, you can activate all this, and the bandwidth can be active now. So let's have a look at this flow again. This is the Kubernetes API server. Then on the kubelet, we have a driver. When create the file, we will have the API, call CNI API. And then it will go into the CNI plugin for the bandwidth. And then to analyze the data, the value, and then to transmit this value. And then in this node, they will have the TC Q disk, TC class, and TC filter. So till now, this will be valid. This is Kubernetes version 1.12. How to use it? If you did not use this before, maybe it's challenging for you to accept this. So you can go to the official website for more details. But now we are still making the preliminary version. You can have a look at APS. They have the ingress browser. Bandwidth. Later version will support for burst, and the configs will be migrated. I work for the upstream, so we will continue to contribute to the development. Let's have a look at the demo. I'm not sure whether the internet works. Can you see this? This is a demo show for flow management. This is a pod file. I can open this for you. This is default without limits for the bandwidth. We can create this. This is the iPerf server, and so we can enter this pod. Or you can find this IP address. The bandwidth is 30 KB per second. This is not only the rate config of runtime, so we can establish another pod. 10 KB. If we don't restrict this, then you can see here this is the default bandwidth. This is new pod config.
这个新建的 pod 的 IP 地址，我们看一下是多少的。是172.172。
The IP address.
然后呢，在实际上同样是
172.17.0.7.
好，这个时候带刚就下来，它大概是
This is the bandwidth. About 1.3.
平均大概是上行大概是9.9，下行大概是9.5。
We have the uplink and the downlink access bandwidth. And average is about 10. So this is my demo. Any other questions? Why you put your network in the annotation for a definition? I think this is very strange. For example, CPU and memory. The network resource is not that emphasizing Kubernetes, so we don't have the scheduling for the network resource. The annotation, I don't define this, but Kubernetes community define this. For the following-up stages, if we can make it stable, we will gradually migrate this into the stack. Thank you. I've noticed your config TC is done in the container, in the host. Bandwidth also done in the host, yes. So for each container, the CNI link, you need to fake in one gateway, a new gateway, yes. You mean the trigger? The intermediate, the intermediate gateway. So from the container to CNI 0, you altogether have 4 gateways. Yes, 4 gateways. 4 gateways. By default. Flannel calls bridge. And we have a vSphere for the CNI. The CNI 0 is 1. The ETC is another an intermediate. Any other questions? If you have any questions, you can contact me in the community. I'm sure that you know me. I am the IBVS author. Thank you.